Hello everyone. Today, my teammates and I are excited to present our project, a digital alarm clock, which we developed during our internship at Emartex. This project was a collaborative effort by myself, Aarti Takwale, along with Pooja Takwale and Priyanka Rathod. Uh, we work under the valuable guidance of Jaya Lakshmi Nayal, ma'am. We are from Singapore College of Engineering, and our branch is Electronics and Communication. Uh, in week 1, we learn how C program is built, means the syntax of C program, and how to actually run the code. I learned about data types, which are basically the different ways computers store information, like numbers or decimal, float, etc. Then we learn arrays, which let us store a big list of items under one name, which is a similar type, which stores the similar type of data. Uh, we also learn the pointers, which are a bit more advanced than arrays. Then to keep the code from being repetitive, we learn loops. Means instead of writing the same line number of times, we can use for loop or while loop for it. By using this, the time required is less. Then we learn to break a big messy program into smaller reusable pieces called as it is known as functions. This makes the code much easier to read. Then at last, uh, we look the how the computer remembers variables, which storage classes, and how to use preprocessor directories like hash include. Uh, yeah. Then in week 2, uh, we studied the tools required for building the project. Means first we saw the MPLab X IDE. Means this is the word processor for coding. It's a single place where we can write, test, and fix our code for microcontroller using languages like C and C++. Then, then after that we saw the picsimlab. Since we was not always using physical hardware, we used this simulator. It acts like a virtual circuit board, allowing me to see if my code works on the screen before ever touching real component. Then after that, we saw the X8 compiler, which is known as translator also. This is the tool that translate the humble readable code uh, we write into ones and zeros that the microcontroller actually understands. Then also along with this, we also learned the different types of digital brains, or we can also call them a memory, such as RAM or ROM. RAM, which is a temporary memory, where ROM is a permanent memory, and how they stores the information. Also we studied EEPROM, then mask-ROM, etc. After that, the goals of the internship. So the primary goal of this internship is to bridge the gap between theory and practical by gaining hands-on experience in embedded system and microcontroller programming. Throughout this entire internship, we are focusing on mastering embedded C to develop, test, and fix code for real world application. A major part of my learning involves interfacing, which is essentially teaching the microcontroller how to communicate with and control hardware parts like LCD screen, LEDs, switches, buzzer, keypads, etc. By working on this practical project, uh, we are building our problem solving skills and technical foundation to prepare for a professional career in system design and development. And then after that, I would request to Pooja Takwale to continue the further slides. This slide outline the essential digital toolkit required to build and run the internship project. As we make the project in software only, so we require software only. To write and manage the code, we use MPLAB XID, which work alongside the X8 compiler to translate our instruction with language the hardware understand. Since we are working with the virtual circuit, picsimlab is used to emulate the hardware, allowing us to test our embedded C program in the real-time simulated environment. Finally, the process result in a hex file, which is the specific file format need to load the program into the simulation and see the project in action. After that, there will be the block diagram. As shown in the block diagram, there will be three parts. It consists of input, that is middle part is the brain and the output. In the input, there is a keypad and power supply unit. Brain consists of MCU, that is a MCU that is peak 16F887, and then at the output part, LCD display, 7 segment display, LED indicator, alarm or buzzer. The at the input side, these are how the system get information. I have a keypad for user input, power supply to keep everything running, and the RTC so that the system know exactly the time it is. After that, the brain. At the center is the PIC 16F887 microcontroller. This is the brain that receive information, process it based on our code, and send out commands. After that, output side. These are how the system react or show information. It use an LCD and a 7 segment display to show text or number, an LED to give a visual signal, and alarm or buzzer to give an audio warning. After that, we will see the working of our project. To be a good clock, the system need to be incredibly precise. The system uses real-time clock, that is RTC, connected via a communication path called I2C. Think of it RTC as a specialist watchmaker that keep the exact time and date. Then the microcontroller, which is the brain of the system, constantly talk to this RTC to get the latest time and display it on the LCD screen for us to see. After that, we use a digital keypad to navigate a menu on the screen and tell the clock when you want the alarm to go off. Means every single second, microcontroller compare the current value with the alarm time you save in it memory. When those two numbers match exactly, MCU send a signal to turn on the buzzer and flash the LED. The alarm stay active until you interact with it. To acknowledge or reset it, ensure the system is user friendly and reliable. After that, we will see the implementation. Instead of using physical part, we build and test the entire system using picsimlab. This allows us to simulate the hardware accurately on a computer. We wrote the instruction in embedded C using MPLAB X IDE. We then use a tool called the X8 compiler, that is to turn that code into hex file, which is essential the final package the microcontroller can read. To make the clock work, we use timer and interrupt for counting. We also connect the RTC module using standard communication path called I2C to ensure the time is always precise. LCD show the current time and whether the alarm is on. Digital keypad let the user set the time or change the alarm setting, like choosing daily or weekly alarm or any particular day if you want to set the alarm. And then the alarm action, when it's time for the alarm, the simulation trigger a buzzer and the LED. The user can then stop or reset it by pressing a button manually. In short, the implementation involved writing embedded C code to manage timekeeping and user inputs. I then use a simulator to verify that the clock display time correctly, save user alarm setting, and trigger the buzzer exactly when it should. Now I request to Priyanka to explain further slide.
Hello everyone, my name is Priyanka Rathod. Today I am going to explain my project Digital Alarm Clock using PIC microcontroller. This is the code we write for the digital alarm clock. This is the header file. This crystal frequency we define, and there is a configuration bits we define for the project. We define also buzzers for alarm and the LED. After all, this is the LCD commands and the data functions. There is a LCD initialization line and display the displaying the text. The main function, the main function, the inside the infinity loop text is display one line by line. This project objective is to designing the real-time digital alarm clock that display the time and date, generate alarm sound. We define the buzzer here. Buzzer makes sounds when alarm reach to the that time. And we see and we build this code first to see there is any error or not. The project is built successful. Then we go to the picsimlab. Here is picsimlab. I already upload my hex file on picsimlab. We can see the output. We can upload hex file again. Load hex file. This is my hex file which I have to upload on picsimlab. The output we can see on the spark part. There is a today timing 5:43 and the date. Today date is 25 Jan and we can see the date and time. They already displaying now. There is error. 1 second. Can clearly see the day, time and date. We cannot. There is a question mark because we cannot add the date on the programming. That's why there is a question mark. And our project is completed. Here we can see the LCD display. The first line showing the time in hours, minutes and seconds. The second line display the date. Here is a displaying the question mark because we can't put the day programming in the program, and we the which are read from the IoT models using the IoT protocols. The RTC model, the DS1307 is used for real-time clock, which are displaying here. The buzzer used for alarm sound. We set the alarm timing. When the timing is done, when timing is reached to that alarm timing, then buzzer get sound. We set their alarm timing is 22:47 and second is 40. When it is 40, the alarm get buzzer. The alarm get buzzer for 5 seconds, and after 5 seconds it get buzzer again. It stop when we stop it manually. Thank you.
At last, I conclude that during this project, we first learn the basics of C programming, including arrays, pointers, and functions, and memory management, which help us to write the structured and efficient code. Then I studied the interfacing of various peripherals such as LCD, CLCD, timers, switches, buzzers, keypads, and many more things, which gave us the practical knowledge of how hardware component communicate with the microcontroller. Then, after gaining this knowledge, we successfully implemented the digital alarm clock project in a software simulation environment using picsimlab. The project allowed us to design a system that can display time, set alarm, and generate alerts, means get buzzed after at given specific time, and all using timer interrupts and peripherals interfacing. Overall, this project enhanced our and embedded system skills, gave us a practical experience in designing real-time applications. Then we gain the practical knowledge of microcontroller and improve our programming and debugging skill. At last, this entire internship was very helpful for us. Thank you.